Okay, so now we're going to try and add and subtract rational expressions that do not have common denominators. So before we get to some harder problems, let's look at this old stuff. If we had 2 9s plus 5 6, these do not have common denominators, so you can't add or subtract them just yet. We have to get common denominators first. So remember what we used to do. We used to look at our denominators and figure out the least common denominator. What would the least common denominator for 9 and 6 be? 18. Right? Don't both 9 and 6 go into 18?
Yes.
Yeah. So now, what did you say? You said 36? If you had done 36, it's not wrong. You're just going to have bigger numbers than you needed. Okay? So, but if we recognize, okay, my least common denominator could be 18, what would I have to multiply this first fraction by?
2.
And it's not just 2, though. It's 2 over 2, right? Because I'm only allowed to multiply by 1. If I multiply by anything other than 1, I'm changing its value. So now, that's going to get me a denominator of 18. What will I have to multiply this side by? 3 over 3. So what I really have, once I actually do that, I'm going to have 4 18ths plus 15 18ths. Okay, so now I can add those two together, and what do I get? 19 over 18. And then, yeah, if you wanted to change it to a mixed number, you could. We should always reduce, though. Can I reduce 19 and 18? Do they have any common factors other than 1? No. So I'm happy if you leave your answer like that. We're going to do the same thing, just with polynomials. All right, so we'll start off easy-ish. Let's say I had one like this. Say it was 5x over 6 minus 2x over 3. I do not have common denominators yet. I have to get them. What am I going to multiply, one or both? What's my common denominator going to be?
6.
6. So he's already 6, so he's fine. I just have to multiply him by 2. So I multiply this by 2 over 2.
I'm so used to saying 2 because I usually do like times 2 on the top and times 2 on the bottom.
Yes. Right. So now when I do that, I'm really going to have 5x over 6 minus what? What does this numerator now become? 4x over 6. And 5x over 6 minus 4x over 6 would actually just be x over 6. Can that be simplified or reduced or anything? No, that's your answer. Okay, step it up a notch, you think?
Yeah.
Yes, let's try. Okay, I'm gonna move over here. Let's try this one, looks pretty good. 4 over 3a squared minus 1 over 2a to the third. All right, so we're going to subtract these two. They do not have common denominators. One of them is 3a squared, one of them is 2a to the third. Here's my recommendation for you. Look at just the numbers first. 3 and 2.
6.
My common denominator would be 6, right? Now, so let's start with that. So I want you to become a 6, so I'm going to multiply this side by 2 over 2. And this side by 3 over 3. If I were to stop right now.
Wouldn't you just put a 2 and then an a?
Yeah.
So then it'd be 6a to the third, and then you wouldn't have to do any variables.
You're right. Look at where I am right now. Look at this denominator is now 6a squared. This denominator is 6a to the third. I'm so close to having them be the same. All this guy needs is one more a, right? Because he's a to the third, he's only a squared. You with me? So I'm going to have to multiply this side also by a over a. So instead of just multiplying by 2 over 2, I'm going to multiply by 2a over 2a. Does everybody see that? And now look at my denominator here. Won't my denominator here be 6a to the third if I multiply all that together? And that's what I want, because on this side, won't I also have 6a to the third? Do you agree? Yeah, so now I have like denominators. Let's just make sure that we simplify the numerators correctly. What would 2a times 4 be?
8A.
8a, and it's all over 6a to the third. Minus, on this side, what's that going to be? 3 over 2a to the third. Oh, not sorry, 6a to the third. Now, in that numerator, what is 8a minus 3? It's 8a minus 3, because they're not like terms, right? So it just stays 8a minus 3, and then the denominator is 6a to the third. Are we done? Maybe, maybe not. We have to check if this can be simplified. Can I factor anything out of this numerator? No. So if I can't factor anything out, there's nothing for me to cancel down here. Because remember, you can never cancel part of a binomial with a monomial.
Can you reduce the 8 and 6?
No, because this is part of a binomial. The only way to cancel any part of this would be if I had another 8 minus 3 on the denominator. Or if I could factor something out of that and get a monomial over here to cancel with it. You can never, ever, 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 ever cancel part of a binomial with a monomial. You can only do monomial with monomial, binomial with binomial. Okay? Sometimes you can take out a monomial from a binomial, but that's why we check. Is there anything to factor out from this? No, there's not. If there was, if I could say I could take out a 3, then I could cancel the 3 and the 6. But I can't take a 3 out of that. I can't take anything out of that. So, I'm done. That's my final answer. Happy day. Right? Okay. Let's try, okay. Maybe we'll try, I'm wondering how, all right, let's try this one. I'll let you try this one on your own, and then we'll kind of come back together and see how this went before we try any more difficult examples. Try that one. 6 over 7t to the third minus 8 over 3t. So if you would like my advice, get your numbers the same, and then worry about the variables. So see what you got to do to get 7 and 3 the same, and then worry about the t's. Remember that once you get your answer, try and simplify it. How do you simplify? Check if there's anything you can factor out from numerator or denominator. Then cancel any monomials with monomials, any binomials with binomials, if there are any for you to do. Okay, we got an answer?
Nope.
Yes.
I'll give you another couple seconds. Okay, let's start with the numbers. How am I going to get 7 and 3 the same? What's the common denominator of just 7 and 3? 21, right? In this case, I'm going to have to multiply them each by each other. So I'm going to multiply him by 3 over 3 and him by 7 over 7. If I were to stop now, this denominator would be 21t to the third, while this one's just 21t. So this one needs to also be multiplied by t squared over t squared. Yep.
Could you just multiply like the 7t for your side by 3t and then the other side by
You could, but you're making your numbers bigger than you need to. You know what I mean? So you would be adding something in that you would have to factor out later. But you wouldn't be mathematically wrong. You could do that. It's just, why bother? You know what I mean? Okay, so on this side, what's my new once I multiply that by 3, what's that new fraction going to be? 18 over 21t to the third, correct, minus 21t to the third. You are correct. So now you have common denominators, guys. So now I subtract the 2. When I subtract these two, what's my new denominator? 21t to the third. It doesn't change, right? And then what's that numerator? 18 minus 56t squared. Now, before we call it a day, yeah.
Shouldn't you do negative 56t squared plus 18 over 20?
I prefer it that way too. I want this to be in standard form. So Alec is saying let's switch these two. Let's write it as negative 56t squared plus 18. Aren't they equivalent? Yeah, I like having the t squared first too, but even more than that, now I can factor something out of this.
2. 2 goes in.
2 goes in. Is there anything else that goes in?
No.
No.
I tried 6, 9. 2, 0.
18 actually goes into both. Yeah. Now, here's something else. I'm not just going to factor out an 18 because I don't like that first term being negative. What might I factor out instead? Negative 18. Guys, watch this. If I factor out a negative 18, how many times does negative 18 go into negative 56?
It says that it's 3.111 when I did it. 56 divided by 18.
Oh, is it?
It isn't a factor.
Oh, I thought it was.
No, it's 2.
Oh, all right. Well, let's take out a negative 2 instead then.
No, you can't do that.
All right, let's start with a negative 2. 2 into 56.
Try.
Negative 28.
Negative, well, now, positive 28, right? And then t squared.
Plus 9.
Careful. Yeah, it's going to be a minus 9 now.
Oh, you changed it.
Yeah. So now I have a 28t squared minus 9. I took
18
out a
goes to
negative.
54.
What?
Just so you know.
Oh, it's 54. Yeah. Okay. So I pulled out a negative 2. I've got 28t squared minus 9. Can I reduce any of that with what's down here? No. Can you guys even see this? You gotta tell me. Okay, good. No, negative 2 doesn't cancel with 21. I can't do anything with the t to the thirds. By the way, is this the difference of two perfect squares?
Yep.
No, because 28's not a perfect square. Too bad, so sad. Otherwise, we could try. So let's write our answer nice and neat. We'd have negative 2, 28t squared minus 9, all over 21t to the third.
What if you have 2 and then in parentheses 9 minus 22 to the second over 21?
You have a positive 2 on the outside?
Yeah.
That's fine. Okay, one more before I end this video and we try a tougher one. What happens if you have something where they don't match? What if I just gave you like, I don't know, how about 3 over 2x minus 4 over 5y? I just want you to try this one where everything is totally different. Get common denominators here, and then we're going to do a tougher example. So, again, if you want my advice, get your numbers the same first, then worry about the variables. Okay, let's start off with our numbers, guys. 2 and 5. What's our common denominator going to be? 10, right? So what do I multiply this one by? 5 over 5, correct. And this one by 2 over 2. Guys, listen. So if you were to stop right now, you'd have 10x as this denominator, and this one would be 10y. Well, that's not the same. Yep.
You can
Times it
multiply
by
both
5y
sides.
over 5y, and then 2x over 2x.
Yeah, what I need, this guy needs a y and this guy needs an x in order for them to match. So I'm going to multiply this side by 5y over 5y and this side by 2x over 2x. Now look at how my denominators will match. I'll have 10xy and I'll have 10xy. So now they're at least the same. So this first numerator is now actually what? 15y over 10xy. Minus, what do I have here? 8x over 10xy. So, when I actually subtract those two, what is it that I get?
Can you combine them or no?
Can you?
I don't know. Yeah.
Can you do... No, they're not like terms. One's an x and one's a y. So the best I can do is write 15y minus 8x. All over 10xy. Now, I may be able to factor something from that numerator. Is there anything that I can take out of this whole thing?
No.
No. Nope. If this had been a, say this had been a 5x, then I could have factored out a 5. If it had been a 9x, I could have factored out a 3. But 15 and 8 don't have any common factors? No. Wait, what?
If it was an 8xy, factor out a lot.
Correct, yes. If they both shared a variable, I could take out. But in this case, they don't.
And if it was y, you could cancel.
You could, right. But in this scenario, that's my final answer. That's the best I can do. Okay? So now we're going to stop this video, and then we're going to try our hardest examples.